Yes, good afternoon, everybody. So I'm going to present you the use of ground motion measurement from space in order to reduce the risk of flood. So let's say I'm going to start with the reading of a leaflet from UN about water and cities. And from this leaflet, we are going to, let's say, outline a few important points. First, that currently, let's say, there is a major human growth, urban growth around the world. So you see that you have something like 2 people per second growing in urban population. This is having an impact because, let's say, people need water. So in order to have the city growing, you need to have more and more water for the people living there. So there is an overexploitation of this water, this groundwater. Then, if you look again in this wavelet, you see that, let's say, normally, because the city are already quite dense, you may have a peripheral growth of those cities, and most of this growth is done in flood-prone areas. So you increase also the risk by growing your city on those flood-prone areas. And we say also that most of the additional buildings are slums, so not very good constructions. And let's say it's a fact that now most of the mega cities are facing water scarcity. So let's say we are in a very paradoxical situation in which this water scarcity is going to induce floods. So let's explain a bit more this paradox. So if you take those 4 items, let's analyze them point by point. So first, let's say, the human growth. This is quite well known. We have a few major megacities growing in the world. This is just the megacities. You see that most of them are in developing countries. And most of them, is not a surprise, are close to the seaside because it's a place that is most convenient for transportation and many other things. Second point, let's say, if you plot with those dots, those big cities, not just the mega cities, you will see that they are either in places subject to coastal floods or in places on which the dash here, on which, oops, you have the, I'm coming back, you have those possible plain flood due to very big rivers that could increase the flow. So let's say, it seems that there is a very strong correlation between this urban growth and the number and the places on which you have those floods possible. So let's say the additional point I would like to pinpoint is this one. It's something that is induced from this growth. It's not obvious, but it's very important. When you are growing your city, you increase its vulnerability to flood. How is that working is quite simple. You may have, in cities, a normal need of water that induces some water pumping and creating no issue in case of water level rise, being sea or river, okay? But when you grow your cities, your water need is increasing a lot, okay? And this is inducing what was mentioned before, a major exploitation of the aquifer, okay? And this overexploitation of the aquifer may create an urban subsidence. So your city is in a way sinking because of this overuse of the water, okay? So the water table is going down. There is a compaction of the material on the top, especially because you increase the weight with the additional construction. And this is creating this increased risk of, let's say, flood. It's not the risk, the vulnerability is increased in this case, okay? Your places that was before not subject to flood may become subject to flood. This, combined, for instance, with the sea level rise, is a major issue for us. So, where is the satellite, let's say, arriving in this matter? There is a technique called the in-situ technique for star interferometry. I'm not going to detail the vocabulary here, but it's a technique that enables to measure from the satellite this ground motion. It's a technique that is, let's say, currently used in many industries like infrastructure monitoring, mining, oil and gas industry, and lately, I would say, in institutional projects. Like for instance, we have many European projects from European Space Agency, but also projects from World Bank, for many research projects that use those techniques. So mainly, this is used normally either for monitoring some water production from ground or to monitor some landslide in some other projects. So we use this ground motion measurement from satellite to determine the area with risk. So how does it work? It's quite, I will not say simple, but easy to understand. Afterwards, more complex to put on more. Imagine you are having some satellite orbiting on Earth like that, and that are able to acquire information over a place, over a city, every time the orbiting around the Earth. Okay? So each time you pass over your city of interest, you can acquire an image that gives you a distance between the satellite and your points on ground. If you do another pass later, and meanwhile your house is moving, you can, step by step like that, derive a complete information on the motion of your points. For instance, here you have this dike here, and we're able, with several acquisition in times, to plot how this dike here is sinking. Okay? So each time the satellite is passing, you are able to derive an information. So talking about big cities and risk of flooding, one of the first example we did was Jakarta. So Jakarta, this is a map of information we can derive from the satellite. So each point in color here, you have a scale here, is a point on which we are able to measure the deformation, and on which, let's say, we plot on this map by a color the motion during this period. So for instance, the speed here, what is important to notice is that we are reaching on those red dots here, speed of about 10 to 20 centimeters per year. So the order of magnitude of this motion is much more higher than the one you may have from just the sea level rise. That is quite important already. It's a major problem, especially also it increase the possible of storm and things like that, the possibility of storm. But here, in this case, you're really increasing your vulnerability, okay? So it's not just this large view. You may also have some very detailed information telling you, for instance, that this part is subsiding a lot, while another part here is quite stable, okay? So it's not just to address your vulnerability here, but also from that you can derive some kind of information about the origin of the subsidence. For instance, in Jakarta here, we discovered that one of the subsiding points was from a beer factory. This beer factory required a lot of water, so this water pumping was creating this subsidence here. So you can here do some kind of additional work to reduce your risk. So it's not just close to the sea. You may have, for instance, that in Ho Chi Minh, where you have this large pattern of deformation here, also due to compaction of ground and change in water table. In addition, with this technique, if you have the luck to have a stable city, like for instance Guyana here, you may have some additional information on water defense. For instance, here, we are able to see that the water defense there is affected by a very localized subsidence. So the city is becoming at risk because the water defense is falling, okay? So if we consider all those information that we can derive from the satellite, we can easily make a map of risk, let's say of much more said vulnerability. We can also, in some cases, when we can identify what is the origin of this subsidence, go to do some prevention to stop that. And in addition, we can also monitor, let's say, the infrastructure of defense for this water intrusion, okay? And all this work is also, like it was mentioned before in all the talk, is an important work of preparation for all the, let's say, organisms involved in this thematic to know that this may happen, and also to prepare additional preparation plan to fight against the floods. That's all. Thank you for your contribution.